The next topic is assignment statements. So, assignment statement is one of the central constructs in imperative languages. It provides the mechanism by which the user can dynamically change the bindings of values to variables. Okay, so assignment is actually assigning some values to a variable. So what will happen? We'll actually change the bindings of values to variables. Okay, so already if it has another value, that will be overwritten by the new assignment. Okay. So simple assignment statements are there, then compound assignment statements are also there. So nearly all programming languages currently being used use the equal sign for the assignment operator. So in C languages we have assignment operator that is equal as the assignment operator, A equal to B. So which means the value of B is copied to or is assigned to A. So all of this must use something different from an equal sign for the equality of relational operator to avoid confusion with their assignment operator. Algol 60 pioneered the use of this colon followed by equal to as the assignment operator, which avoids the confusion of assignment with equality. ADA also uses this assignment operator. ADA. In ADA and Algol 60 we have colon followed by equal to. The design choices of how assignments are used in a language have varied widely. In some languages such as Fortran and ADA, an assignment can appear only as a standalone statement and the destination is restricted to a single variable. Okay, there are however many alternatives. So in Fortran and ADA, actually this an assignment means that should be a single standalone statement and the destination is restricted to a single variable, and we have many alternatives. So conditional targets. Okay, so Perl allows conditional targets on assignment statements. For example, consider this dollar symbol, flag, question mark, and dollar count 1 colon dollar count 2 equal to 0, and this is actually equivalent to, this is a statement in Perl language that is equivalent to if dollar flag. So this is actually a variable name dollar flag, that is if this dollar flag is true, then dollar count 1 equal to 0, count 1 equal to 0, else count 2 equal to 0. Okay, this is how Perl allows this conditional targets, and its equivalent is like this. Okay, then instead of this simple assignment statements or assignment operators, we have compound assignment operators. A compound assignment operator is a shorthand method of specifying a commonly needed form of assignment. Okay, the form of assignment that can be abbreviated with this technique has the destination variable also appearing as the first operand in the expression on the right side, as in A is equal to A plus B. So this is a compound assignment. Okay, so that is A, the destination is A, and that appears as the first operand in the expression on the right hand side. Okay, compound assignment operators were introduced by Algol 68. Okay, and this have been slightly or this have been adopted by the C language, but there is slight differences in the form and are part of the other C based languages as well as Perl, JavaScript, Python and Ruby. The syntax of these assignment operators is the concatenation of the desired binary operator to the equal to operator. For example, sum plus equal to value. Okay, so we know that in language this compound assignment statement is the destination appears on the right hand side, and this has a different variation. Okay, this type of syntax is used in Algol 68, and C also adopted this one, but some changes are there in the syntax. So for example, we know sum is equal to sum is equal to sum plus b. So that is denoted by sum plus equal to b. Okay, so syntax is the catenation of the desired binary operator to the equal to operator. Okay, this is plus is the binary operator, and that is concatenated with equal to. This is equivalent to sum is equal to sum plus value. Okay, the languages that support compound assignment operators have versions for most of their binary operators. Then unary assignment operators. The C-based languages Perl and JavaScript include two special unary arithmetic operators that are actually abbreviated assignments. Okay, they combine increment and decrement operators with assignment, operations with assignment. The operator plus plus for increment, minus minus for decrement can be used either in expressions or to form standalone single operator assignment statements. Okay, so we can use, we know what is unary assignment operator in C language, that is plus plus or minus minus. So this can be a standalone single assignment statement, or this can be used in expressions. Okay, inside expressions we can have these operators. They can appear either as prefix operators, meaning that they precede the operands, or as postfix operators, meaning that they follow the operands. In the assignment, sum is equal to plus plus count. So the value of count is incremented by 1 and then assigned to sum. This operation could also be stated as count is equal to count plus 1, sum is equal to count. Okay. And if the same operator is used as a postfix operator, as in sum is equal to count plus plus. Okay, so that is the assignment will happen first, then this variable will be incremented. So the assignment of the value of count to sum occurs first, then count is incremented. The effect is same as that of the two statements, sum is equal to count, then count is equal to count plus 1. An example of the use of unary increment operator to form a complete assignment statement is count plus plus. Okay, so this is a complete unary assignment statement. Okay, count plus plus. So what happens? The value of this count will get incremented by 1. Okay, so which simply increments count. It does not look like an assignment, but it certainly is one. Okay, so when we see this, it doesn't look like a an assignment, but it is an assignment statement. It is equivalent to the statement count is equal to count plus 1. So when two unary operators apply to the same operand, the association is right to left. Okay, for example, in count plus plus, okay, so the count is incremented, and then that is negation count plus plus. So the count is in first incremented and then negated. Okay, so it is equivalent to negation, which means minus count plus plus, okay, rather than minus count plus plus. So which means unary operator, when two unary operators apply to the same operand, they are right associative. Remember that. Okay, they are right associative. So minus count plus plus. So that is the count is incremented first, then it will get the sign. Okay. Then assignment as an expression. In the C-based languages Perl and JavaScript, the assignment statement produces a result which is same as the value assigned to the target. It can therefore be used as an expression and as an operand in other expressions. This design treats the assignment operator much like any other binary operator, except that it has a side effect of changing its left operand. Okay. For example, in C, it is common to write statements such as while ch equal to get char not equal to e of. So here this assignment statement actually gets a value. Okay, that is, it actually produces a result, and that result will be the value assigned to the target, that is the value that is assigned to the variable ch. Okay, so if the value of ch is not equal to EOF, then this will be executed. Okay, the next character from the standard input, usually the keyboard, is gotten with getChar and assigned to the variable ch. The result or value assigned is then compared with the constant uf. If ch is not equal to uf, the compound expression, this one is evaluated. Note that the assignment must be parenthesized. In the languages that support assignment as an expression, the precedence of the assignment operator is lower than that of the relational operators. Okay, clear? So, in this case, it should be parenthesized, because assignment operator, the precedence of assignment operator, that is actually lower than this relational operator. So, to perform this first, we need to parenthesize them. Okay. Without the parenthesis, the new character would be compared with the uf first. Then the result of that comparison, either 0 or 1, would be assigned to ch. Okay. So, we do not need that case. Okay. And the disadvantage of allowing assignment statements to be operands in expressions is that it provides yet another kind of expression side effect. Okay. This type of side effect can lead to expressions that are difficult to read and understand. An expression with any kind of side effects has this disadvantage. Such an expression cannot be read as an expression, which in mathematics is a denotation of a value, but only as a list of instructions with an odd order of execution. Okay. So, what we say is that the major disadvantage of allowing assignment statements to be operands. So, here an assignment statement is acting as an operand, that is ch equal to getChar. Okay. And it actually provides some expression side effect, and this side effect can lead to expressions that are difficult to read and understand. In some situations, this side effect has that kind of a problem. Okay. So, for example, the expression a is equal to b plus c equal to d divided by b minus 1. Okay. So, this denotes the instructions assign d divided by b to c, because that is given within parenthesis. Then assign b plus c to temp, then assign temp minus 1 to a. So, this will be evaluated first because it has a parenthesis. Okay. Then this b plus the c will be evaluated, then that value minus 1, and that is assigned to a. Note that the treatment of the assignment operator as any other binary operator allows the effect of multiple target assignments, such as sum is equal to count is equal to 0, okay, in which count is first assigned to 0 and then the count's value is assigned to sum. Okay, so here we have multiple target assignments. This form of multiple target assignments is also legal in Python. There is a loss of error detection in the C design of the assignment operator that frequently leads to program errors. In particular, if you type if x equal to y instead of if x equal to y, which is an easily made mistake and which is not detectable as an error by the compiler. Okay, what will happen? Instead of that, the assignment will happen there instead of comparing them. Then we have multiple assignments. So, several recent programming languages including Perl, Ruby and Lua provide multiple target, multiple source assignment statements. For example, in Perl, we can write like this. We have most of the programming languages has this kind of an assignment, that is $first, $second, $third equal to, and that is given within parenthesis, and the values, target values are also within parenthesis 20, 40, 60. The semantics is that 20 is assigned to first, 40 is assigned to second, 60 is assigned to third. If the values of two variables must be interchanged, okay, suppose we need to interchange values of two variables, this can be done with a single statement, first comma second, second comma first. So this is very easy. This correctly interchanges the values of first and second without the use of a temporary variable, at least one created and managed by the programmer. Okay. And assignment in functional programming languages. All of the identifiers used in pure functional languages and some of them used in other functional languages are just names of values. Okay, names of values. As such, their values never change. For example, in ML, names are bound to values with the val declaration, whose form is exemplified in the following: val cost, that is equal to quantity into price. Okay. So that is, in ML language, names are bound to values with the val declaration, val cost equal to quantity into price. So what happens? So we have cost appears on the left side of a subsequent val declaration. That declaration creates a new version of the name cost, which has no relationship with the previous version and which is then hidden. F hash has a somewhat similar declaration that uses a let reserved word. Okay. So in ML we have val cost is equal to quantity into price. So cost is a variable and its value will be quantity into price. And this F hash also has a similar declaration, but it actually uses a reserved word let. Okay. So the difference between F hash let and ML's val is that let creates a new scope, whereas val does not. Okay. In fact, val declarations are often nested in let constructs in ML. Okay. So in the case of let, F hash actually uses let, and this let will actually create a new scope for this variable, but this val does not create a new scope, and val declarations are often nested in let constructs in ML. Okay. Then we have mixed mode assignment. Fortran, C, C++ and Perl uses cohesion rules for mixed mode assignment that are similar to those they use for mixed mode expressions. That is, many of the possible type mixes are legal with cohesion freely applied. ADA does not allow mixed mode assignments. Okay. In a clear departure from C++, Java and C# allow mixed mode assignment only if the required cohesion is widening. Okay. Then it can include at least approximations. Okay. So an int value can be assigned to a float variable, but not vice versa. Okay, because these languages will allow only mixed mode assignment if the required cohesion is widening. So from int to float, that is actually a widening. Okay, so that is allowed, but float to int is not allowed. Okay, mixed mode, we know mixed mode expressions. So there we have mixed values. Okay, so that is a different operands will have different types. So here also we are trying to assign a variable to another variable, but their types are different. Okay, suppose A is equal to B, but we are actually expecting A and B of the same type. But if some particular languages allow mixed mode assignment, it means that A and B can be different languages, I mean different type variables, but this language should allow cohesion. If cohesion is allowed, then we can allow. And again, the cohesion means we actually need a widening cohesion. Okay. So this kind of mixed mode assignment is possible. Then disallowing half of the possible mixed mode assignments is a simple but effective way to increase the reliability of Java and C# relative to C and C++. Okay. So this is actually disallowing half of the possible mixed mode assignments will actually increase the reliability. Of course, in functional languages where assignments are just used to name values, there is no such thing as a mixed mode assignment. Okay. functional languages means assignments are just used to name values, and there is no mixed mode assignment in the case of functional languages. Okay, so we were discussing about this assignment statements. So we discussed about simple assignment, then compound assignment, then unary assignment, then again how this assignments in functional languages like ML and F hash, and we know the multiple assignments, the case of multiple assignments. Then we can see assignment as an expression. Okay, all this. Okay, that is about the topic assignment statements.